In today's lecture, we will revisit PROC format first, then introduce PROC report. We have been using PROC format several times in this course. There are two key statements, value and invalue, to define format or Informat. First, we will look at the value statement. The statement creates a format that specifies character strings to print variable values. We can define the values for both numeric and character variables. We will look at examples of both. For numeric variables, we can define a formatted string for a single value or a range of values. We will look at an example in SAS. Here in SAS, as usual, I have the SAS code with the log, and then we'll place the output here in a moment. First, we're going to read in the heart data set. Next, we have the corresponding code. We'll first run the code and then talk about the code. In this example, we defined the smoking groups based on the number of cigarettes the patient smoked per day. And we can see that here. In the second PROC procedure, we applied the smoke format to the variable smoking, and we get a short table with smoking groups as we have defined. So notice here is the first frequency table. Here is the second one. In the first one, smoking is defined by the number of cigarettes, whereas in the second one, smoking is defined by the new format that we created. Now, one thing to notice, when writing in the format, notice here we've named the format smoke. When we call the format down here, we place a period after the name. You should see the format name change color. If we were to leave off the period, this would not work. For character variables, we can also define a formatted string for a single value or a range of values too. We'll look at this in SAS as well. Let's first run the SAS code and then talk about the output. We need to add a $sign to the format. We can see that right here. In this example, we only show it for the single value. We redefine the blood pressure values to be more informative. However, we limit the length to be 20. We can see from the output table on the bottom that the format for high blood pressure is complete and others are not due to the limitations of length. And so again, we see that down here. You can also define multiple labels for same values from the same variables. Only multi-label enabled procedures such as PROC means, PROC tabulate can use multiple labels. All other procedures in the data steps recognize only the primary label. Let's look at some examples in SAS. First, let's run the PROC format statement. Next, we'll run two different examples. So the primary label is either the label which is first assigned if the same value or range is specified for multiple labels, or the label which is the first range of interval values that contain certain value. In example 1, we apply format smoke A, which is defined as a multi-label to the smoking variable. We can see from the output non-smoker is the only label for 0, Both light smoker up to 5 and light smoker up to 10 can be the label for value 1 through 5. We define the 1 through 10 equal to light smoker up to 10 first. However, after sorted by SAS, 1 through 5, light smoker up to 5 comes first, and it is used as the primary label for 1 through 5. I added comments next to the code to show the sorted order. For 25 to 60 is not used because it comes last and is completely nested under 20 less than high, or 20 too high. High is used to indicate the maximum value. So if you don't know the largest number for the variable, you can use high. Similarly, low can be used for the smallest value excluding missing. The invalue statement creates an Informat for reading and converting raw data values. Again, we'll look at an example in SAS. First, we'll run the code. Let's look at the log. Here we define 3 Informat live, live A, and live B. Since live A and live B are all character informats, they need the $sign. But if we define live C as a format by value statement, we don't need a $sign. However, live C cannot be used to format data during input process as Informat. Live B cannot be used with put function. Next, we'll look at some more examples in SAS. First, we'll run the code. We apply 3 informats in the example test. We can see our input is string for a live and a live 2 and a number for a live 3. But after we applied the informat in the print data set, the output display numeric values for a live, shortened values for a live 2, and string values for a live 3. And we can see that here in this table. Test 1 is the example to show that format cannot be used during the input. We will get an error message since live C is not an informat. Informat and format can be used with input and put functions. Variable status contains string values. We apply the informat live and live A to it and get a live 1 and a live _2 as new variables using the input function. Then we apply the format live C to a live 1 to get a live 3 as new variable using the put function. However, in test 3, the live B informat cannot work with the put function together. There are more about format such as create format from dataset and create picture format. We didn't cover in this lecture. You can learn those on your own. Next, we look at PROC report. PROC report is a powerful procedure. It combines features of the print, means, and tabulate procedures with features of the data step in a single report writing tool, which can produce a variety of reports. There are some concepts I'd like to highlight. The first is to plan the layout of the report. During this stage, we'd like to decide what variables to include, how to use them, how to display them, and in what order do you want to show the column row. The second is to use the compute blocks to add on to the report. We can add variables that are not in the input data set, define display attributes for a report item, and define the value or label for report items. The last one is to use break lines. This can help us add text and calculated values for the report. The statements I will introduce for this lecture for PROC report are listed on this page. I will demonstrate the usage using the following examples and explain each one with the example. This example is for the column statement. We would like a heading for all columns to be displayed in 2 rows in the table. Parentheses are used to group together columns you want a column heading. So in the column statement, we will put in the parentheses for all content to create the heading for columns. Let's look at an example. First, we will run the code. Split option helps to create 2 rows for the overall heading. We like the second heading to be for 3 living status variables. So we add parentheses outside the heading we want together with 3 different variables. We then added a variable comment, which is not from the data set to the last column with a different heading. By default, if a variable has a label stored with the data set, as we defined here for those 3 variables, procedure uses the labels as the cell label. If not, variable name is used. Or we can use define statement to change the label. We will see examples later. The by statement is used to create tables by the by variable. Not sorted can be used to force SAS output tables without sorting. However, the output table will be separate by the variable according to the values. In this example, we can see it produced multiple tables for the same living status. So let's look at the example in SAS. Again, we'll first run the code. So here we have status alive with 3 observations, and here we have status alive with another 3 observations. So to use the by statement, as we have learnt before, it is better to sort the data first. Contents options can be used to modify the text for the table contents created in the ODS destinations. We will have an example in the last to show the usage. The define statement tells SAS how to use each item. We need one define statement for each item. With the statement, you can define the label, format, style, alignment, and other features of the item. Group option in the define statement groups the item or variable. Let's look at an example in SAS. First, we'll run the code. What we want to show is the total invoice and the total percentage of the cars by origin and car type. So we group both origin and type by add group option in the define statement, and tell SAS we'd like to look at a summary and percentage of invoice. Here we'd like to look at the sum and percent sum. So there are statistics we would like to look for invoice. Different from what we have learned from PROC tabulate and PROC report, we can use commas for nesting. So invoice is followed by sum and percent sum with parentheses after the comma. We can see that here. We tell SAS to line up origin to the left by using a left option in define statement and line up the type to the right. Also, we want to display the total invoice in a dollar format with using the format equal $8 and the percentages with maximum 2 decimal points. And we can see that through here. We also change the color for total invoice to be red, which is in the style color equals red, and make the cell to be 2 inches wide for the percentages, which is the style equals width equals 2 inches. And we can see that here, 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 and here. And so I should have said 1 inch, not 2 inches. What if we want to show the same statistic for different variables with different labels? One way to do it is to assign different names. Let's look at an example in SAS. First, we'll run the code. In this example, we called the mean age start mean 1 and mean age death mean 2, and used the define statement to give them different labels. Also, we can define them to have different formats and styles. In this example, I'd like to introduce the across and order option in define statement. Across option can help to create a cross tabulate for the defined item. In this example, we apply the cross to sex and group to smoking status. We can see from the output that smoking status is displayed in rows and sex is displayed in columns. We add order equals freak to determine smoking status. The default order for freak would be from the lowest to the highest count, which is the reverse order if we want to compare it with order equal freak in the PROC freak, as we can see here. This example is for the usage display option for the define statement. If you want to produce a report with one row for each observation, and those variables in the report are going to be all numerical, then you will need to add display in any of the defined statements. Otherwise, the procedure will give a summary from all observations. If you have any categorical variable which is not grouped, you won't need this option. The out equal option generate a SAS dataset from the procedure. So first, let's look at the SAS code. First, we can run the code. Oops, and I realized I ran a little bit further than I meant to. We didn't need to go all the way down to slide 15. So let me just rerun the piece we need for this slide. And what we're going to focus on is actually going to be here in the output. Now I am going to switch back over to the slides to look at the output, and you'll notice that the line numbers here don't match quite with the slides, and they probably don't match what you have on your computer, but what is in the log will be the same. From the log, we can see that line 835 to 841 are for a report with categorical variable, and the output data set contains 5,209 observations. From line 842 to 848, we can see that without display, the report for two numerical variables only generated a data set with one observation. And the data set is right here. It is a summary of the weight and age from all observations from the original data set. From line 849 to 855 with display, the report procedure generated a data set with 5,209 observations. We'll look at another example. This example will show that compute block, break, and R break statements. We'll look at the SAS code. First, we'll run the code. Compute and incomp statements start ends a compute block containing one or more programming statements that PROC report executes as it builds the report. Break produces a default summary as a break. R break produces a default summary at the beginning or end of a report, or at the beginning or end of each by group. Before/after options tell where to start the break into compute. Line provides a subset of the features of the put statement for writing customized summaries. In the example, we use compute before page and line statement with text to put a title in the beginning of the table. And we use the compute after and line statement to put some text at the end. Computer sex and break after sex tell SAS to summarize by gender groups. The compute sex with if statement assign total to be the label for the row. If we don't add this compute block, male and female will be used as the labels. So here would be female and here would be male. Compute after in our break after tell SAS to compute the whole data set. Total is used as the label by default. Here in the slides, we have labeled the different pieces. On this slide, we'll look at the slide instead of looking at the SAS code, since we have the different pieces annotated, but the SAS code will be available for you on Canvas. In this example, I'd like to introduce the computed variables and call define statement. If we would like to add a variable to the report, which can be computed during the define statement, we need to list it with the computed option, then we use a compute block to specify how this variable will be calculated. In this example, we calculated average invoice using total invoice divided by number of cars in the first compute block. The call define statement is often used to write report definitions. The required arguments for a call define statement are column ID, attribute name, and value. Let's look at the second compute block. We want to highlight the columns of invoice in yellow and change the color of a car type to orange if the total invoice is larger than 1 million. Here we use two call define statements. The first one, we use call as the column ID since we are computing invoice. So the call indicate the column ID would be for the invoice columns including the total invoice and number of cars. The attribute name is style, and the value of the attribute here we use is yellow for the background. In the second one, we use type as the column ID. Variable name with quotation marks can help to identify the column. We still use style as the attribute name, but use orange color as the value. The call define statement, third compute block, use row as the column ID. This means we selected all columns here to apply the attribute. So we can see we changed the background color for the whole row here. In the last compute block, I just want to show that we used formatted variables in line with text. In this report, the last line summarized the total sale from all origins. So we have text for the total sale for all origins is used, and the variable invoice sum to automatically generate the report with the value here. There are also style options for PROC report. In this example, we applied style to the report and to the lines. You can test the code to code out and figure out how the attributes change by using different values. In addition, the contents option and PROC report statement tell SAS to change the secondary level label for the table of contents and bookmarks list in the ODS destination. We can see from the PDF file that the secondary label is changed to what we put into the contents. There are many statements options we didn't cover in this class. SAS help documents and YouTube videos are good resources if you need to learn something we didn't cover. Let me know if you have any questions.